This is the question of perimeter and its area. In this question is in a parallelogram PQRS, PQ is equal to 25 centimeter, QR is equal to 15 centimeter, PL is perpendicular to SR and PM is perpendicular to QR. If PL is equal to 10 centimeter, then find PM. In this problem, the figure of that problem is here. We have to draw a parallelogram PQRS. PQRS, where P, Q, R, S. The measure of PQ is 25 centimeter. The measure of PQ is 25 centimeter, and the measure of QR is equal to 15 centimeter, and PL is perpendicular to SR. Then we have to draw a perpendicular PL which is perpendicular to SR, which is height of the given parallelogram PQRS, and the measure of PL which is perpendicular to SR is 10 centimeter. PL is equal to 10 centimeter, and PM which is perpendicular to QR. So we have to draw PM, perpendicular PM, which is perpendicular to QR, and we have to find the measure of PM. In this problem, if we let the base SR, which is 25 centimeter, because of in the parallelogram opposite sides are parallel and equal. So if PQ is equal to 25 centimeter, then SR will be also is equal to 25 centimeter, and QR is 15 centimeter, then it will be also equal to PS, which is 15 centimeter. So if we consider base SR, then the height corresponding to the base SR will be PL, and if we consider the base is QR, then the height of that base will be considered PM, and as we know that the area of the parallelogram is base into height. So area of parallelogram is equal to base into height. Here base SR and the height is PL. So SR into PL. If we consider the base is QR, in this case the height will be PM. So area of parallelogram is QR, which is base, and PM, which is height, SR into PL. Here we have to put the measures of QR SR and PL. So the measure of QR is 15 centimeter, then 15 into PM in LHS part, and in RHS part SR into PL, where SR is base and PL is perpendicular height or altitude. So the measure of SR is 25 centimeter into the measure of PL. The measure of PL is equal to 10 centimeter in the above figure. So here we have to solve for PM. PM is equal to 25 into 10 upon 15. Here we have to simplify. 5 3s are 15, 5 2s are 10, which is equal to 25 into 2 upon 3, 25 into 2, which is equal to 50 upon 3, and we have to write 50 upon 3 in mixed fraction, 16 whole 2 by 3 centimeter. So the measure of PM will be 16 whole 2 by 3 centimeter. Here we have to get the measure of PM. Measure of PM, which is equal to 16 whole 2 by 3 centimeter. And the new question, which is related to the triangle. In a triangle ABC, question is, in a triangle ABC, the measure of AB, which is equal to 15 centimeter, the measure of BC, which is equal to 8 centimeter, and the measure of AD is equal to 7.5 centimeter. Then we have to find first area of triangle ABC, and second B is altitude EC. So in the solution of this problem, first we have to draw the related figure. Here triangle ABC, here the vertices A, B, C and the perpendicular which is given AD, and the perpendicular which is given that EC is perpendicular on AB, and AD is the height of the triangle, and measure of AD is equal to 7.5 centimeter. Measure of BC is equal to 8 centimeter. Measure of AB is equal to 15 centimeter. So the solution of this problem, we have to use the formula of area of the triangle. In this case, in this process, we know that the area of a triangle ABC, area of triangle ABC, which is equal to 1 by 2 into, if you consider base BC, then the height will be AD. So 1 by 2 into base BC, and the respective height is AD. And again we have to write the area of the triangle ABC in the other way. If we consider base AB, then the respective height is EC. So one by 2 into base will be AB and respective height is EC. We have to find area of a triangle ABC and altitude EC. Here we have to calculate EC, which is the altitude of the triangle when base is AB. A by 1 by 2 into value of BC, which is equal to 8, and value of AD, which is equal to 7.5. So one by 2 and 1 by 2 is cancelled out from both sides, and we get AB, which is equal to 15 centimeter into EC, which is equal to 8 into 7.5. So EC is equal to 8 into 7.5 upon 15, and 7.5 2s are 15. So EC will be equal to 8 upon 2, and 2 4s are 8. So EC is 4 centimeter. So the measure of EC is equal to 4 centimeter, which is the solution of B part. And in the A part, we have to find the area of a triangle ABC. So first part, this is the second part, and first part, in the first part, area of a triangle ABC is equal to 1 by 2 base. Here we consider base will be AB, and its respective height is EC. So 1 by 2 into AB into EC, and measure of AB is equal to 15 centimeter and measure of EC, which is equal to 4 centimeter. So 2 to the 4, which is equal to 15 into 2, which is equal to 30 centimeter square. So the area of the triangle ABC, which is equal to 30 centimeter square, and altitude DC of the triangle ABC, which is equal to 4 centimeter. And we head to a new problem, which is the rectangle EFGH. Question is EFGH is a rectangle in which EF is equal to 28 centimeter. EF is equal to 28 centimeter and EH is equal to 22 centimeter, and PQRS and P, Q, R and S. PQRS are midpoints of the sides of the rectangle, EFGH, Here we have to find the area of the shaded region. So to find the area of the shaded region. The figure of that problem is here. EFGH is a rectangle. In this case, all the interior angles of a rectangle will be 90 degree and opposite sides of the rectangle will be equal to each other. This means EF is equal to HG. Because of that, EF and HG are opposite sides, and HE is equal to GF, which is also opposite sides. So FG is equal to EH and EF is equal to HG. Here the dimensions of EF will be 28 centimeter and the dimension of EH or HE, which is 22 centimeter. PQRS, P, Q, R and S are midpoints of the side of the rectangle E, F, G, H. So the midpoint of FG is P and midpoint of HG is Q and midpoint of HE which is R and midpoint of EF which is S. So meet the vertices P, Q, R and S. Then we have to get a quadrilateral PQRS. PQRS. And the shaded region will be quadrilateral PQRS. And we have to calculate the area of the shaded region PQRS. Here S is the midpoint of EF. So ES and SF will be equal to each other. So here EF is equal to 28 centimeter. Then ES and SF will be 14 centimeter. 14 centimeter ES and 14 centimeter SF. In the same process, HE is equal to GF which is equal to 22 centimeter and P is the midpoint of FG. So GP and PF is equal to each other, are equal to each other. So measure of GP is equal to 11 centimeter and measure of PF is equal to also 11 centimeter and EF is equal to HG and HG, the measure of HG is equal to 28 centimeter. The measure of HG is equal to 28 centimeter and Q is the midpoint of H and G and Q is the midpoint of H and G. Line segment HG, so HQ will be equal to QZ. So measure of HQ and QZ will be 14 centimeter. 14 centimeter HQ and 14 centimeter QZ. Here R is also the midpoint of HE. In this case, the measure of HR is 11 centimeter and the measure of RE which is also 11 centimeter. So we have to find the area of the shaded region PQRS which is covered by line segment PQRS. If we subtract the area of triangles, these triangles, triangle PGQ, triangle QHR, triangle RES and triangle PFS. If we subtract from area of a rectangle, these four triangles, area of these triangles, then we have to get the area of the shaded region. So area of shaded region, area of shaded region PQRS is equal to, here area of these triangles are equal, because of that these triangles are congruent. When two triangles are congruent, then its area will be equal. So the area of PFS, triangle PFS, and area of triangle RES, and area of triangle QHR, and area of triangle QZP is equal. So area of centered region PQRS is equal to area of a rectangle, EFGH minus here four triangles which is same in the area. So we write 4 into area of a one triangle, 4 into area of, here we consider triangle PFS, area of a triangle PFS. Here we have multiplied by 4, then the area calculated this triangle, this triangle, this triangle, and this triangle. So area of a rectangle EFGH is equal to length into breadth, which is EF into, here breadth is HE and length is EF. So EF into HE minus 4 into area of a triangle PFS. As we know that area of a triangle is 1 by 2 base into height. So 4 into 1 by 2. If we consider base is SF, then the respective height is PF. So base is SF and its respective height is PF. Here we know all the measures of EF, HF, SF and PF and put in this and put the measure of EF, which is 28, measure of HE, which is 22 minus 4, 2 to the 4, 2 into SF, measure of SF, 14, and measure of PF is equal to 11. When 28 and 22 is multiplied each other, we have to get 616 minus the product of 2, 14 and 11, which is 308, and after subtracting 308 from 616, we get 308 again centimeter square. So the area of the shaded region PQRS will be 308 centimeter square. This is the question of chapter ratio and proportion. Question is, two numbers are in the ratio 2:5. The larger number is 15 more than the smaller number. Find the numbers. First of all, we have to let the common ratio of both numbers, which is x. Then in the solution of the problem, we have to clearly tell the numbers, then the numbers will be 2x and 5x. If we multiply the common ratio in the given ratio, then we have to get the numbers exactly, which is 2x and 5x. The relation between both numbers, larger number and smaller number. The larger number will be 15 more than the smaller number. Then the equation will be 5x equals 2x plus 15. Here we have to solve like terms. 5x minus 2x is equal to 15, and the difference of 5x minus 2x is equal to 3, which is equal to 15, and then x equals 15 upon 3. After simplification, 15 upon 3, 3 5s are 15, the value of x is 5. Then clearly I tell you the numbers are 2x, which is equal to 2 into value of x is 5, then 2 into 5, which is equal to 10, and 5x, which is equal to 5 into value of x, which is 5, then 5 into 5 is equal to 25. So the numbers are 10 and 25. Here the smaller number will be 10 and larger number will be 25. In this process, we have to solve a new question which is related to ratio and proportion. Again, question is Raj has a bag of marbles. Raj has a bag of marbles with a ratio of 4 blue marbles. 4 blue marbles to 7 red marbles. 7 red marbles. If he has a total of 132 marbles. How many are blue? How many are blue? In this problem, the ratio of the blue marbles to red marbles is 4:7. In this problem, first we let the common ratio of both marbles, which is x, and the numbers of blue marbles is 4x after multiplication of common ratio, and the number of red marbles is 7x, and in which the total marbles is equal to 132. Then after we frame the equation of the problem and we solve, then we have to clearly find the number of blue marbles. So in the solution, first let the common ratio of the both marbles. Let let the common ratio is equal to x, then the number of blue marbles, then the number of blue marbles is equal to 4x, and the number of red marbles is equal to 7x, and total number of marbles is equal to 132. Then according to question, sum of blue marbles and red marbles, which is equal to 132. So we have to write 4x plus 7x, which is equal to 132. In LHS, both terms are like terms, and we have to add 4x and 7x, which is 11x is equal to 132, and value of x equals 132 upon 11. X equals, after simplification of 132 upon 11, we have to get 11 manja 11, 2 and 2, 22, 11 2 ja 22. Then we have to get value of x equals 12, and then we have tell the clearly number of blue marbles and red marbles. Hence, the number of blue marbles is equal to 4x. 4 into value of x is 12, and product of 4 and 12, which is 48, and the number of red marbles is equal to 7x. Here 7 into and value of x is 12. 7 into 12, which is 84 marbles, and we have to tell in the problem how many are blue marbles. Then the number of blue marbles are 48. And again, one question is considered from the chapter ratio and proportion, which is the ratio of kids to adults. The ratio of kids to adults in a party is 5:3. Is 5:3 if there are 18 adults. 18 if there are 18 adults are at in the party, at in the party, how many kids are there? How many kids are there? This is the question of ratio and proportion, in which we have to first let the common ratio of the kids to adults, which is x. In the problem of the solution, first we let the common ratio which is equal to x, and given ratio is kids to adult, which is 5:3. Then the number of kids, which is equal to 5 into x, which is equal to 5x. So the number of kids is equal to 5 into x, which is equal to 5x, and the number of adults, which is equal to 3 into common ratio, which is x, and product of 3 and x is equal to 3x. According to question, in the problem, the number of adults are 18, and here the number of adults are 3x. Then according to question, 3x will be equal to number of adults, which is 18. Then 3x equals 18, which is the equation form of that question. Then the value of x equals 18 upon 3, and the quotient of 18 upon 3 will be equal to 6. 3 6 are 18. Then we have to find the how many kids are there. So the number of kids in the party which is equal to 5x, which is equal to 5 into value of x is 6, 5 into 6, and product of 5 and 6 is 30. So the number of kids in the party, which is 30. In the same way, we have to take one question which is again related to ratio and proportion. The question is, in a cricket match, the ratio of runs scored in a cricket match the ratio of runs scored by team A to team B, by team A to team B is 5:3 is 5:3 if team B scored 120 runs. If team B scored 120 runs, 120 runs, how many runs did team A score? How many runs did team A score? In this question we have to find how many runs did team A score in a cricket match. And in this problem the ratio of runs scored by team A and team B is 5:3. So again we have to let the common ratio of the given ratios, which is x. In the solution of the given problem, first we have to let the common ratio which is equal to x, and after multiplying the ratio of team A and team B by the common ratio, we have to exactly get the runs scored by team A and scored by team B. So runs scored by team A, which is equal to 5 into common ratio is x, which is 5x, and runs scored by team B, which is in the ratio team B tells 3. So runs scored by team B is equal to 3 into common ratio, which is x, 3 into x, which is 3x. So here the runs scored by team A and team B is 5x and 3x. In the problem, if team B scored 120 runs, then we have to already know the value of runs scored by team B, which is 3x. And in the problem, this is given that team B scored 120 runs. In this case, the value of runs are equal to each other. So, according to question, 3x will be equal to 120 runs, and value of x equals 120 upon 3, and quotient of 120 and 3 is 40. So the common value of common ratio is 40, and then we have to find the runs scored by team A, which is 5x. Hence the runs scored by team A, which is equal to 5x, 5 into value of x is 40, 5 into 40, the product of 5 and 40 is 200. It means in a cricket match, the runs scored by team A is equal to 200 runs. This is the 4 problems of related to ratio and proportions, which is solved in your copies.